Okay guys, so welcome to the lecture on geology and the Earth's resources. So we were talking about challenges and concerns with toxicology and issues associated with environmental health. Well, we need to look at the environment and look at the basic resources the Earth provides to us. And a lot of that comes in the form of what minerals, what natural resources we can obtain from the Earth, and then how do we use them in hopefully an environmentally friendly way. So let's look at the basics of the Earth, just kind of the brief geology. The Earth is made up of these things called tectonic plates. All the continents sit on tectonic plates. So we have North America plate, we have the South American plate, African, Eurasian, etc. All sorts of other plates that make up the Earth, the actual physical aspect of the Earth's surface. And these plates are all bordering each other. And what we'll notice is that the tectonic plates are constantly moving. Sometimes they slide past each other, sometimes they run into each other, sometimes they go under each other. And this is what creates the various types of environmental impact, environmental events, like earthquakes and tsunamis and things of that nature. So ridges are often formed when two tectonic plates push towards each other. Okay, so two plates push against each other and they basically kind of buckle and push upward, creating a ridge. Now when one plate slides under another, this is what we call subduction. So one slides down, the other one slides over the top. Sometimes the one sliding over the top lifts up a little bit, but then may level and flatten back down. But the one sliding under generally gets ground down and pushed deeper and deeper into the earth, and to some extent it basically liquefies as it reaches the molten core and crumbles and disintegrates. This is why sometimes we will never find fossils of certain things, because if they're on a plate that subducts and goes underneath another, it's gone. A lot of the ocean plates do this when they hit continental plates. They hit the landmass plates. The ocean plate slides under and gets buried underneath the land plate, and we're never going to see what was on that ocean plate. And then when the plates slide past each other, let's say they bump sides, slide past each other, kind of rubbing against each other. This is what can lead to earthquakes. Now, how hard they rub and the friction that creates, that dictates the magnitude of the earthquake. All right, so the plates are constantly moving. The good news for us is when the plates move around, they push up rock that may never have been exposed before, or they shift things around. Now, granted, if we are living near an area that has the boundary of two plates, we need to really consider how we build, because that area is going to be more prone to tectonic plate movement. Your building, your structural nature of your buildings needs to be different than if you're in the center of the plate, where you're probably never really going to get an earthquake or things like that. All right, so the plates are made up of rock. Rocks actually make up a large part of the Earth's physical surface. So the rock is a solid, sometimes cohesive aggregate of minerals. Now it might be one mineral type or combination of multiple minerals. When we look at rocks, we break rocks up into three different categories or classifications. We have igneous rock, we have sedimentary rock, and then we have metamorphic rock. Okay, so three big types of rocks that we want to be comfortable with. All right, so we'll get into these a little bit more. But to take a look at rock, and what makes rock and what happens to rocks, we'll take a brief look at the rock cycle. So here's an example. Rocks change shape, they change form, they change composition based on temperature and pressure. Those are the two key variables, temperature and pressure, that determine the rock's composition. So then you change the temperature or the pressure the rock undergoes or experiences, and it changes the rock's nature, the formation or the type of rock that you have. The breaking down of rock ultimately produces sediment. And when we'll talk about sedimentary rock here in a little bit, this is literally just all these little rock particles that have been crushed, packed, smashed together, and compressed into different types of sedimentary rock. So when we look at our rocks, again, the three types are igneous, metamorphic, and sedimentary rock. Okay, so again, remember the three rock types: sedimentary, metamorphic, igneous. Pressure, temperature are the keys that determine the rock type. All right, so let's take a look at igneous rock. Igneous rock is the most common type of rock in the Earth's crust. It is made from magma, basically magma that has solidified. It's cooled, so that liquid stuff in the Earth's core, that is liquid magma, as it cools, when it comes up to the surface of the Earth, it solidifies into different types of igneous rock. Now, depending upon the type of pressure the igneous rock is compressed under or formed under, it'll give us these different varieties of igneous rock here. You have andesite, basalt, diorite, gabbro, etc., obsidian, pumice, and so on. Don't worry about memorizing all those. You guys take a geology course, you'll go through all that, you'll get to learn about those. And why do we have certain rock types in different parts of the world? So for our purpose, just looking at the big rock types: igneous, metamorphic, and sedimentary. All right, so metamorphic rock is a rock that's usually modified by heat, pressure, and different chemical agents. So as that rock is formed, it can be compressed into slate, or think about marble, how hard and just solid marble is. Or you get schists, quartz, these other types of metamorphic rock. So again, certain amounts of heat, pressure, and different chemical agents are what cause metamorphic rock to be formed. And then when we look at sedimentary rock, this is the accumulation of those little tiny weathered pieces of the other rocks that compress, and they just get compacted. The picture on the left here, this one here, is showing us these different layers and layers and layers of deposited materials that got compacted over and over and over. So a lot of times when we're looking at fossils, we use sedimentary rock. Each layer represents a window of the Earth's history. Different things happened, different living organisms were present, etc. So the sedimentary rock tells us kind of the history of the Earth. Now, to the right here, it shows us different examples of sedimentary rock, things like limestone, sandstone, shale, etc. These are, again, often the rock types we look for when we're trying to find fossil fuels. So resources that we use, things like coal, oil, natural gas, we're usually looking for sandstone, shale, etc. to tell us, hey, that's where that stuff, those resources might be. Okay, so again, the mineral content, the rock content of the Earth is very important for us. There's economic geology and mineralogy that is a field of science looking at what is the value of the rock, so, or rock minerals, etc. So when we look at things like metals, these are the 6 main metals that we consume, or the largest quantities, the top 6. You got iron, manganese, chromium, aluminum, copper, and nickel. So those metals are consumed in the greatest quantity globally, but they're not available globally. So the availability of those metals is what determines or dictates your price. So why is aluminum so expensive? Because it's what it takes to get the aluminum and how much is available. Why is chromium expensive, and so on? Again, it's the availability determines the price, then the method of obtaining these rocks, or extraction method, is what will influence a lot of our environmental issues or create some significant environmental issues. Because mining for minerals is not very environmentally friendly. I mean, it beats the heck out of the earth and produces a lot of environmental problems. So we'll talk a little bit about those throughout this lecture. Some of the concerns about how we're actually mining for these different minerals. So, okay, so not all metals have value to us. There are non-metal mineral resources, things like gemstones and different precious metals. So rubies, sapphires, diamonds, etc. These are non-metal mineral resources that have huge value. And then stuff like sand and gravel. Now remember, sand and gravel is part of soil. It's a natural part of the environment. There's huge value there. And we mine massive amounts of sand and gravel globally and use it in all sorts of different things. Just think about the roads in the area. How much of that is made up, how many roads are gravel and sand is mixed in to create concrete and things like that. So, there's some huge issues here when we start talking about how we use these resources. All right. Now, the fossil fuels are probably one of the main non-metal things we want to mention and talk about that lead to some significant environmental issues. All right, so fossil fuel formation started back during the Carboniferous period. So we're talking hundreds of millions of years ago. We had these swamps and forests and oceans. And when things died, the vegetation died in those swamps, the plants were compressed over the top of dirt, underneath dirt, underneath water. And that built up and built up and built up and compressed that dead organic material of the plants, compressed it down into coal. It did not decompose. That's the key to form coal. You have to die, get compressed, but don't rot. And then as that compression continues to happen, heat and pressure continues to compress the dead material into coal. It takes hundreds of millions of years of pressure and heat to compress dead organic material into coal. That's why it's a non-renewable resource. But since it was an organic thing at one time, there's a lot of carbon stored and sequestered in those organisms. When we take that coal out and we burn it, well, then we're releasing all that carbon that was stored. Same thing goes for oil and gas. A lot of carbon, because oil and gas is formed originally from living organisms. There used to be plankton living in the ocean hundreds of millions of years ago that died and got compressed. Sand, silt, water, temperature, heat, etc., pressure, and just builds up, compressing down the organic material, and eventually led to the formation of petroleum and natural gas formation. So again, removing these things can beat up the environment, but then when we burn them as a source of fuel, we're releasing all that stored carbon that used to be contained within these things. That carbon then goes into the atmosphere. We're burning the stuff faster than the carbon can be brought back into living plants and producers, thus an increase in global CO2 levels, which is one of those driving factors behind climate change. So, all right. So, in our next lecture, we're going to talk a bit about some of the environmental effects of extraction of minerals and different resources. So we'll look at what happens when we need to extract these resources and what does that do to our environment.